Hello and welcome everybody to the first session of the Comment Room. So I'd like to introduce our first speaker, Juan Pablo, and he will give a speech on the computer vision motion capture system. Yeah, with that, the stage is yours.
Okay, thank you, Robin. So let me, there you go. So as Robin said, I'm going to present you my project, which is Computer Vision Motion Capture System. And as you might know, computer motion capture is used for many applications. For example, in game development or filmmaking. But I want to focus especially on how we can use this technology for customized avatars to use them in platforms like the metaverse. So, with the need for remote work and collaboration, virtual meetings have become increasingly common. And virtual meetings offer so many benefits, like accessibility to connect with people from anywhere and anytime, resulting in higher attendance rates, like this global conference right now. Virtual meetings are also effective because virtual meetings eliminate the time spent commuting for physical locations. It also allows participants to make better use of their time, leading to increased productivity. And it also has features to enhance collaboration in real time. And the metaverse is taking virtual meeting to the next level because users can immerse in virtual 3D world where they can move around and explore. The metaverse allows a special interaction, which is also more natural. Users are represented as avatars that can be personalized, and customization of avatars and the environment itself adds flexibility and creativity to the meeting. However, virtual meetings still face some challenges, and the one I want to address in today's session is the limited nonverbal language, which is vital for effective communication in an interpersonal interaction. So you will see, when it comes to meetings in virtual event platforms, like in the metaverse, in most cases, users employ avatars that recreates their physical appearance. Having avatars that actually looks like you and behaves like you with natural facial expressions enrich the nonverbal communication. But why this is important? Why is important to have realistic avatars that mimic our expressions? Well, the importance of this lies on first, it reduces the feeling of impersonal communication that we experience when interacting with still avatars. Also, in face-to-face communication, a significant portion of communication is non-verbal, and the visual cues provided by facial expressions can signal agreement, disagreement, confusion, or interest to the speaker. Also, the availability to see and interpret gestures enhances the empathy and the feeling of connection with others. Sometimes simple text or voice is not enough to express emotions effectively, as body language and gestures do. And another reason why expressions are important in avatars would be to help to clarify intentions and emotions, reducing the risk of misinterpretation. And why not to add a personal touch to the avatars? And well, since we started messaging using messaging services like WhatsApp, emojis have been always used to express our feelings and react in our conversations. But especially Apple, more specifically the Memoji, are custom animated avatars that users can create to resemble to themselves, allowing them to express their emotions and personality in a fun and personalized way in a message. And in 2018, with the introduction of iOS 12, Apple enabled the use of Memoji into video calls. So now a Memoji, or your customized avatar, can be used to reflect your facial expressions of movements in real-time video calls by using just the front camera of your phone, well, of your Apple, or of your iPhone, if you have one. And having an avatar that looks just like you make our conversations richer and more engaging. The more realistic they look, the better is our emotional response to the virtual character. As technology advances, techniques to create accurate and realistic avatars have become simpler and with better results. For example, video games, the video games industry, are doing some things about this regard. For example, the NBA 2K23 are implementing the creation of realistic avatars by just scanning the face. So with few photos, you are able to create your own avatar with a very realistic look, or sort of. As you see, these avatars, they look realistic, but something is quite not right. So the problem we would face when creating realistic avatars is that when we try to create something realistic, we may fall short into realism and end up creating an uncanny valley effect. And for those that are not familiar with the term, the uncanny valley refers to the discomfort people feel when a character looks almost but not quite human. This is explained by the relationship between the appearance of the character and our emotional response. The more human-like the character, our response becomes more positive and more empathetic. However, there is a point at which the character becomes almost human, but quite not, like the examples that I showed you before. At this stage, our emotional response takes a sharp dip, creating a feeling of uneasiness and discomfort. This area is called the uncanny valley. This negative emotional response is caused by unnatural appearance, expression, or movements of something like looks very human, but does not behave 100% accurately. Then again, as the character becomes more realistic and indistinguishable from a human, the emotional response rises again and the discomfort disappears. So in the case of creating avatars, if we want a positive response, we have to make them look more than humans. It means like more realistic. And actually, the MetaHuman, which belongs to Unreal Engine, is working on that. So with their system, you can get something like this. You can customize your avatar based on different predefined models, and then just adjust by little tweaks the avatar, and you can get very realistic looks. And basically, you can build any face. So how do we get from a simple photo to a model that looks and behaves like this? Well, to start with, what Unreal Engine do in this MetaHuman system is that first they take pictures of the performer to create the 3D model. And by solving the triangulation of all the points in the face, it is possible to create the 3D model of the performer. So again, this is just the 3D model compared with the actual movements of the performer. And the final result will be something like this. And well, actually, you can, again, use your Apple to do such a thing. Because as I mentioned before, Apple introduced the Face ID in 2018. And it is used to unlock your phone, but it can be also used to do motion capture. And the technology of the Face ID consists in 3 different types of cameras. The first one is a dot projector, which emits more than 30,000 invisible dots that are projected into the face to build the unique facial map. Then an infrared camera that reads the dot pattern. And finally, the flood illuminator, which is invisible infrared light to help identify these infrared dots in dim conditions. Then by reading these infrared dots, Face ID is able to build a detailed 3D map model of the face. As I mentioned, the Face ID was originally created to unlock your phone by only looking at it, but people have used also this detailed face map to do motion capture. And well, by using 30,000 invisible dots, you can create models that do very subtle movements, like the guy doing here. And well, continuing with Apple technology, few months ago, the Apple Vision Pro headset was released. And they use also the Face ID technology to allow the users to enter group meetings showing their own avatars. So during the usage of the Vision Pro headset, the user has all his face covered. But Apple is using again the Face ID to create a system that uses the same technology, and by implementing machine learning, it is possible to represent realistically the gestures of the person that is using the Vision Pro. So when you are chatting, people will see your eyes, your hands, and your true expressions. Now, I will show you the system that I developed for doing motion capture using computer vision. But to start with, I will take you through all the process that I did, starting with the model. So to build the model of my own head, I used Maya, and I used reference image as guides. As you can see, this is the front side, the left side of the image, and then how I was building the model. So for the sculpting process, I modeled the shape of the head and sculpted details such as the ears, the nose, the lips, and the eyelids. So this is a video of the ear, the nose, and this is the final base model of the head. Similarly, I added the model of the teeth, for which I used other reference images to resemble my own teeth, and added the texture to make it look realistic. And in the same way, I created the model of the eye and its texture to make it look realistic. Afterwards, I created the texture for the face model. And in order to do this, I used UV mapping in Maya, which is like unfolding the 3D model. And in this way, textures can be created in a way that they grab the 3D model entirely. So this is the UV map, which unfolds this face model. And with these limits, with these bounds, I was able to create the texture that was going to grab the entire 3D model. And well, back in Maya, I made each of these materials with the respective texture, specularity, and some other material features. So this is the final result. When I put together the models of the eyes, the mouth, with the respective textures and everything inside the 3D model of the head, the result was something like this. The next step was to grow some hair in this model. So once I was satisfied with the model, I had to create this hair system, which include the eyebrows and the beard. In the case of the eyelashes, they could be considered hair too, but I found it easier to create them as polygons. Now, Maya contains a powerful tool named XGen, which is used to create all styles of hair and fur. And this is a comparison of how the hair generated by XGen looks like in the viewport, which is the editing window in Maya, and how it looks after being rendered. Whereas when illumination conditions, specularity, and textures of the materials are displayed properly. And well, also for the sake of completion, I created another hairstyle for my avatar. As you saw, the first one, it was with hair loose, and the second one, which is this one, had the hair tied up. Also, for this hairstyle, I added some other details like flyaway's hairs in the nape, which is the back side of my head, and also the sideburns. And this is the comparison side by side of the three elements that the three hairs that are contained in the hair system, and this is the one generated by XGen: the beard, the eyebrows, and the hair. However, I have to mention that even though XGen generates quite realistic looking hair, these hair are instances that can only be seen in Maya, either in the viewport or rendered. In other words, XGen hair is not exportable. Therefore, to be able to export the model with hair, eyebrows, and beard, everything needed to be made out of polygons. So the next step was to build a new hair system made out of only polygons. For my first attempt of building a hair system made out of polygons, I used a tool in Maya that allows you to paint hairs over surfaces, and then turn off each of these surfaces into polygons, resulting into individual hairs made out of tubes, like these ones. Unfortunately, with all the geometry added to the model, the file size became very large, making it hard to render the changes to the model in real time. And this was not desired for the project because having a smooth performance was essential when doing motion capture. Then the second attempt was to use one strategy that game developers used to avoid this high polygonal model. This strategy consists in create a similar look with geometries called hair cards. And these hair cards have texture. By using this technique, the amount of instances in my model was reduced drastically, and the reaction time of each of the model's joint was improved. This would make possible to receive the data from Python and then perform all the movements in the model without any latency. And well, these are the hair cards that I used in my model: the eyebrows, the beard, and the hair cards for all the hair in the head. This is the layout of the hair system built by Texture using hair cards, and this system was the one that I used for the model during the motion capture. Well, this is just for you to see the comparison between the hair systems with each of the methods used. And as you can see, there is not much difference in appearance, but only the hair system built with hair cards provided a viable solution for the motion capture system. And before going to the next step of the system, I just want to highlight some details I added to my 3D model in order to resemble more to me and to look more realistic. So first was the skin molds in my face and left ear, the lacrimal in the eye sockets, and the inner side of my left eyebrow is also a bit toolsed, like here. Also, flyaway hairs in the nape and sideburns were added, and the ears were containing detailed helix structure. In the case of the face of the mouth and teeth, I have a diastema between my two frontal teeth, and I wanted to add some lip texture just to make it more realistic. The next stage was the rigging, and the rigging needed for the head movements and facial expressions was done similarly as the one that I made before for one hand project. And rigging consists in how each joint influence certain region of the model. So when you move a certain joint, how much of the model will move depending on the movement of this joint. As I mentioned, I did another rigging for a hand, and I used this model for validation purposes because during my bachelor thesis, I built a system with a virtual hand that reproduced the movements of a glove. And it was just a matter of controlling the virtual hand using computer vision. In this case, for the system that I was proposing, the only difference was that instead of using sensors inside the glove, I was going to use computer vision. I was going to use computer vision to move the virtual hand. And implementing motion capture in a hand is much easier by the simple fact that the hand has less landmarks to track. Here are a few poses to see how the joints behave and how their weightings and influence affect the model. So in the left, you see the top eyelid of one of my eyes and how it moves when I close the eye. And the other one is just to try out some jaw, neck, and eyelids movements. Now, for the landmarks, how to extract them, how I was going to extract the facial landmarks to map them into the model from my real face. So initially, the idea was to put color markers in the joints of each finger, and by applying color filters, extract the relative position and obtain the angles of the fingers. First of all, I had to select the easiest colors to mask out, or in other words, the easiest color to identify and isolate these colors from others. And you might have seen that in filmmaking, they use green screens to add special effects in post-production. And sometimes they also use blue screens. The reason is that these two colors are easy to distinguish and contrast from human skin. So I use these two colors to try out color extraction. And the one that gave me better results was the green one, as you can see in the video. And this is the result of doing motion capture in the hand using color markers. As you can see, it's quite accurate. When I fold the fingers, also the model do so. But an issue I faced with these color markers was that when working with only one camera, the camera of my laptop, I was losing one dimension, having as a result readings of position in space lacking of depth. And the biggest disadvantage came when trying to implement this solution to the whole hand, because when flexing the fingers, some fingers always obstruct a clear read of the color markers. And as I mentioned before, color markers are a suitable solution when working in 2D spaces, but this was not my case for the facial motion capture. So I was looking for another solution, one solution that was more robust. And then I find MediaPipe, which is an open source framework developed by Google that employs machine learning to infer 3D landmarks. It offers high fidelity tracking for hands, face, and some other solutions like hand gesture, body pose, object detection, face detection, image segmentation. And here yesterday, when I was preparing the presentation, I recorded this directly from the MediaPipe sample, which you can use online and with the camera input of your laptop. And you can run the model either on the CPU or in the GPU. And as you can see, in both cases, CPU and GPU, both of them do inferences in real time with no apparent latency, which is good for motion capture systems. So I use MediaPipe solution to detect and track the landmarks. As I mentioned, it only requires only one single camera input and outputs geometry data in real time. And it is natural to think that at some point when rotating the hand or the face, some landmarks will be hidden to the camera, but MediaPipe is robust enough to make proper estimations of the positions of all the fingers because it treats the hand geometry as an entire as an entire mesh instead of separated points. So you can keep track of the hand regardless you are rotating it, closing the fingers, or whatever. Then transferring the data of the angles between the fingers from Python to Unity was done with sockets, and the response was quite good with not apparent latency. So in the left, you are seeing just the MediaPipe inference and the data on Python. And then this data was transferred to Unity using sockets. And this is the final result on real time. So I just showed you the solution for hand mesh, but MediaPipe also offers a solution for face mesh. And since the motion capture system using computer vision worked properly for the virtual hand, it meant that it could be also implemented on the 3D model of my head. So this is the mesh, the face mesh MediaPipe does. And this is an example of using the MediaPipe model on my face. Well, I have to say that something important, that the way in which MediaPipe delivers the coordinates is respect to the top left corner of the frame of the camera. And in the case of the hand motion capture, this was irrelevant because the angles were obtained by vectors and not by the coordinates of these landmarks. However, for the facial motion capture, I was dealing with displacements instead of angles. For this reason, I was needed to transform the data to coordinates referred somehow to the face itself, so to extract the relative position changes. And this is how I did it. First, I took the reference landmark to be the nose, which is the central landmark. And I extracted the vectors contained in this facial mesh. So first, one of the axes was contained between the extremes of my face to have the horizontal axis, then the vertical axis from the landmark in my forehead and the landmark in my chin, and the result, the last vector was obtained with cross product by doing cross product of the other two vectors. One thing I have to say is that MediaPipe offers 468 landmarks, but not all of them are relevant. Not all of them change accordingly to the movement of the face. So I had to choose important landmarks, either for referencing the coordinate system or for the movement of the avatar. Well, once I decided which landmark was going to be the central landmark and which landmarks were going to be important and which ones were going to be used for referencing the frame, I did some correction to put always the landmark of the nose to be in the central position of the frame. So here in this video, in the first window, you will see the real-time video with the landmarks drawn over my head, over my face. Then the second window shows the relevant landmarks isolated with reference coordinate systems. And the third window is the correction of rotations, only for pitch and roll, which is when moving the head up and down and while tilting the head side to side. The next step was to capture the gaze. To do so, I built a pixel-based iris tracker. With the information of the landmarks, it was possible to get the region of the eyes, and by counting the amount of dark pixels, I could know where the eyes were looking at. Then, for a more precise reading, I decided to calculate the mean of pixels of both eyes and move them together. In the same way, from the landmarks of the eyes, I could determine whether the eyes were closed or open. The way to do so was as simple as calculating the ratio between the horizontal and the vertical distances of the eye bounds. Um, However, this time, the reading of the eyelids was independent one from another, so the model could blink and wink. And in the same way, using the aspect ratio between the boundaries of the mouth, I could determine the opening of the jaw. And by counting white pixels, I could determine if the teeth were shown or not. And well, having obtained all the landmarks of interest referenced to a point in the nose and the rotation angles of the face, the data could be sent to Unity to control the model. The Unity project was basically the same that I used for the motion capture test with the hand. And the first test to perform motion capture was only using the jaw. The model made in Maya and the computer vision task made in Python were joined in Unity successfully. And well, this is the final result of the Bartol environment. Many expressions can be achieved with this motion capture system. And this is a real-time video demonstration. Well, I have to say that the motion capture system developed was satisfactory because considering that the input image came only from a single camera and the predictions of the landmarks, calculation, data transferring, and all the processes was held by my CPU instead of the GPU without having latency, gives the idea of how powerful MediaPipe as a tool is to do inference in real time. But on the other hand, I have to admit that this system has some limitations. For example, the one that I mentioned about MediaPipe, that not all the landmarks have influence when the user moves the face. So you cannot get subtle face expressions like, I don't know, moving the nose or moving a little the lips. But for what I was looking for, the system that I was looking for, I was happy with the outcome. And we just have to remember that controlling an avatar using motion capture is not about how much the avatar resembles to the user, but how realistic this avatar may look and how smooth are the movements. And also how the movements of the user maps into the rigging of the virtual avatars. Just to conclude, I want to say that motion capture is a technique that has been largely used in video games or filmmaking, but also is also finding its ways through applications as controlling avatars in platforms like the metaverse. And compared to its early years, motion capture has become faster, better, and lower cost in terms of resources, and this makes easier to anyone to develop proficient motion capture systems. But I can bet that for technology regarding to motion capture, the best is yet to come. Um, this is it. If you want to see full details of the project, you can visit this link, which is my website.
Great. Really interesting talk. Yeah, there's a QR code.
The QR code for the project.
You can leave it on for a bit so people can use their phone maybe. Yes. Really impressive, especially how many like different independent systems you were developing to achieve the full avatar is really interesting. So I've seen like a few motion capture like for avatar, but like usually it's like built into the product, right? When you have a headset that has already built-in motion tracking. So this shows how much effort it is. All right. We we didn't have any viewer question yet. Just here. Congratulations for Rama for your amazing work, I guess. Um, all right. Yeah, as you mentioned in the end, the best is still to come for motion capturing. I'm also following these developments a bit. What are your thoughts on the new system proposed by Meta, where they it's not only about the motion capturing, but also like encoding it so that you can use it in the VR applications and stuff. So they recently published this pixel codec avatars, which is really impressive, like realistic avatar. And I'm not really that familiar with the technical details, but I think it is like a much more involved process to scan like different gestures of a person, right?
I was also reading about a system developed by NVIDIA, and what they did was to train machine learning models uh, with voice, so the model could replicate the lip movements only out of voice, only out of voice commands. Like right now, I'm speaking, and the model was trained to imitate the lip movements when pronouncing the words that were there. And it's very amazing because you don't need an image to be processed. You just need the voice channel. But in this case, you don't have these little gestures that you can do when doing actual motion capture in the face.
Right. Yeah.
You don't know. Like maybe they can, in a few years, they can come up with something newer that merge both systems to have a more accurate motion capture system.
Right. We're just on time. I think we can have like 5 more minutes in case somebody has questions. Yeah. I also wondered, like, since you had to combine different systems in your motion capture design, did you had any conflicts when you combined like the well, you had the eye movement, but also like blink detection and like the mouse. So like sometimes some systems may be conflicting with each other, I could imagine.
Yeah, true. I have to admit that I cheated a bit. I had to separate different systems because, as you said, some of them were conflicting with each others. For example, when I was moving the head, I had to disable the movements of the eyes or of the mouth because moving the head around would trigger like oh, he's opening the jaw. So I had to separate them, but isolatedly, each of these systems work properly, like when blinking or moving the eyes around, opening the mouth, uh, worked properly.
Right. Yeah, it shows all these possibilities. Just the combination requires some sort of additional fine tuning, maybe.
Hmm. Yes, or to create like more robust models using machine learning. Uh,
Right.
More cameras is what they do for movies, for video games. But I was just
All right.
using the camera of my laptop, like this one over here.
Uh, yeah, this is a low-cost system that you are developed here, so it's still very impressive for the accuracy that you can achieve here for the face. And I wondered if you have like any like follow-ups or like how you uh, will continue
Developing.
this development. Yeah.
Yeah, it would be nice to keep working on this, especially with the new technologies that have come, that the ones that I mentioned from Apple, this Face X that allows you to have very precise avatars with only using the camera of your phone, like this one.
Yeah.
Um, well, why not also to learn how to do proper textures? Because before I mentioned that you should avoid the uncanny valley effect when doing realistic avatars. And I feel that I fall into this uncanny valley with my model. But
Especially with the extreme gestures. Yeah, like the face. I think it's pretty solid result, but like when you are doing like the different emotions, then yeah, this is actually a really tricky part. Like I think even Facebook is struggling with that to
yeah,
make it look natural, and like you have to again fine tune this in the end if you want to really use this on a larger scale.
and actually
Mm,
that's the reason why Meta is opting for avatars more cartoonish to avoid this uncanny valley, um, like the ones they have here. This is the kind of avatars you would see in Meta.
yes, I have
Uh,
seen them in Horizon. They have like some sort
Exactly.
of a default emotion, so it's always the same sort of simple emotion, but it looks kind of cute, and nobody is expecting a realistic human. Actually,
Not yet. But
not yet.
we will see where it takes. Maybe one day we will be like the movie Ready Player One, that everything is so accurate and so smooth. Uh,
Absolutely, it's definitely possible, and we see like the beginnings nowadays, as you mentioned, with other companies. Um, all right, I know you have another talk that you have to get ready for in a few minutes, so
yes,
let me just yeah. Thank you again very much, Juan Pablo, for this amazing talk, and I would say we are closing the session here. If anybody has more questions, please ask on our Discord. Uh, Juan Pablo will
I'll
be
be
able
there.
to answer them. Um, all right, so see you guys on the
Thank
next
you,
session.
thank you everybody for assisting, and thanks Rama for coming and passing by. Ciao.